Hi guys, welcome to the last session of complex numbers. In the last class, we have seen how to calculate square roots, how to calculate root of a number or a square of a complex number. In today's short video, we are going to look at the last particular concept, which is called as conjugates. So till now, we haven't discussed about this conjugate, but it's a very, very interesting as well as important topic in your complex numbers. Right, so let's begin by understanding what is a conjugate. That's very brief about me. I'm going to skip this part. Right, so what is conjugate of a complex number? The definition of a conjugate, if you have a complex number z, which is of the form a plus ib, then the conjugate of z is represented by z bar. There's going to be a bar on top of it, z bar. Okay, this is how a conjugate is represented. So the conjugate of a complex number z, which is z bar, it is written as a minus ib. A minus ib. Okay, the definition has another meaning, which is actually the true meaning of it. The definition of a conjugate is such a way that if you multiply z with z bar, you get a real number. Only a real number. There will not be any imaginary part to it. So a number which is going to be multiplied with your z such that the result is a real number is called as a conjugate of your complex number. So when the complex number is of the form a plus ib, if you take it as a minus ab, you'll notice what is happening. A plus ib, when you multiply it with a minus ib, you will get the answer as a square minus ib whole square, because this is of the form a plus b and a minus b. This gives you a square plus b square, because I square is -1 and negative into negative becomes positive. Okay, so when the complex number is given in a simple form like this, you can know that when you multiply it with a minus ab, you will get a real number, and that becomes a conjugate. But this is a very interesting and important definition for you to keep in mind. Z is whatever number is there. If you multiply it with the conjugate, the answer should be a real number. Such a conjugate or z bar, so such a z bar is called as the conjugate, because I can give you a question which is not directly of this form, which is not directly in this form. Then you cannot take z bar in this a minus ib form. So you need to think, what should I multiply it with so that my end result becomes a real number? But 99% of the times, your z will be given in the simple rectangular form only. I hope you remember, this is called as the rectangular form. Right? Now moving on. So what are the properties of conjugate? So there are few properties of conjugate, and we're going to look at it. Firstly, when you have z1 plus or minus z2 and you're taking the overall conjugate of the result, it is same as separately taking conjugates and adding or subtracting. Okay, so if you are adding two complex numbers and taking the conjugate for the overall addition or subtraction of these two, it is same as taking individual conjugates and then performing the addition or subtraction operations. That is the first property. The second property of a conjugate is the same thing which is happening with the multiplication also. So it is not just for addition and subtraction, it is also true for multiplication. So if you are supposed to multiply two complex numbers and get its conjugate, the resultant's conjugate, it is same as taking the conjugate of the two complex numbers individually and then multiplying. Right? All right. And it is also going to be nothing but the modulus of the resultant. It is also going to be nothing but the modulus of the resultant of z1 plus into z2. Okay, it is going to be the resultant of z1 into z2 modulus. Right. The next thing is for division. Again, the same property exists for division also. Same thing what we discussed for multiplication, addition, subtraction, division also it holds true. So the basic four properties of mathematics, when you apply to conjugates, you can separate out the conjugates, when instead of doing it for overall number. We can do it for separately two different things and then add them, subtract them, multiply them, or divide them. The next property of conjugate is interesting. It is about the power. The power of a conjugate of a complex number is same as the complex number raised to the power and then taken the conjugate. So the both give you the same meaning. So if I give you 3 plus 5i whole power 6, this is same as 3 minus 5i whole power 6, because if z equal to 3 plus 5i, I want z power 6. So it is same as z bar whole power 6, which is z bar is 3 minus 5i raised to the power of 6, right? So the power also, you can take the conjugate inside or outside. It doesn't affect. Next thing is something called as the inverse of z. Now inverse of any number basically is a number when you multiply it with the original number gives you the result 1. So if I call x, or if I take z, and if I multiply it with a number called y and the resultant is 1, then y will be called as the inverse of z. This is the definition of inverse. We have seen the definition of inverse in matrices also, right? So inverse is basically a number which when multiplied with other number, or if you want to find the inverse of x, you multiply it with such a number such that the resultant is 1. So you will need 1 by x. So when it comes to complex numbers also, the basic definition holds true. Okay. So z into z bar, when you multiply a number with its conjugate, will give you the modulus of z squared, right? So your inverse of z is 1 by z, because 1 by z into z basically gives you 1. So if you want this 1 by z, what you need to do is you keep this z to the right hand side and take this modulus square to the left hand side. So you notice that the z bar will be as it is, and this is actually square. This is z square. Okay, so you will get 1 by z is equal to z bar by mod z whole square. All right, so this is the formula for your z bar. You can find z bar also as 1 by z, and you can find what is 1 by z. You can find out the inverse of a number by writing it in the denominator. But yeah, there's another way of writing it, which is basically conjugate of z divided by modulus of z whole square. Okay. So z inverse is basically the same thing that I've written. This is actually, so please keep in mind, this is not into 2, this is square. This is square. Okay. Moving on. So let us look at where do we apply this conjugate. So if I ask you, find the answer for the division of these two numbers. Now till now we have seen how to add, subtract and multiply. And when if you remember in the second video, I've said that division will be coming later. So here I'm now dividing two complex numbers, 3 plus i5 and 2 minus i5. So the process to divide this, basically what you do is you multiply and divide the number by the conjugate of the denominator. So the denominator is 2 minus i5, its conjugate is 2 plus i5. So you multiply and divide your given number with the conjugate of the denominator. The advantage of this is the denominator becomes a real number, and you will multiply the numerators to come up with a complex number. So this will become your new answer. Okay, so what is your new answer? If you want to write down your final answer, that is, it is minus 19 by 29 plus I 25 by 29, where your real number part is minus 9 by 29 here, and your imaginary number part is 25 by 29. So this is one of the applications of conjugate. It is helpful in finding the division. So it is a bit difficult for you to divide directly between do the division between two complex numbers. So what you do is you convert the division into multiplication. How are you doing that? By multiplying with the conjugate. So the denominator becomes a real number and numerator is the multiplication of two complex numbers, which you already learned. Okay. So how do you plot Z bar in Argand plane? Let's take a look at this. Let us start with an example of my Z equal to 3 plus 2i, which means my real number is 3, my imaginary number is 2, my Z, this is my Z, 3 comma 2. This is your Z. So my vector for Z will be written like this. So if I change my color and if I draw in green my Z bar in terms of rectangular coordinates is supposed to be 3 minus 2i. So your 3 is still here, but negative 2 is here. So this is your 3 comma minus 2, which is your Z bar. So your vector for Z bar will be in this manner. As you can see, the real number part will remain the same. The imaginary number part will become negative. So your Z and Z bar are mirror images, where the mirror is your x-axis. Your mirror happens to be your x-axis. This is the mirror. So if I ask you a number, this is your Z. Okay, if I ask you this is your Z, or let me draw it in red only because we have mentioned Z. And so this is Z2. If I ask you what is the conjugate of the Z2, so you have to draw the mirror image of this with respect to the x-axis. This is your x-axis. So the mirror image will be, look at this, 1, 2, 3, 4. So it is 1, 2, 3, 4 bottom. So this is going to be your Z2 bar. You don't even need to know what it is. Just the mirror image will give you the correct answer. All right. So that's all about conjugates and drawing of conjugate, my friends. With this, we will end the complex number topic. I hope you realize that the complex numbers is only complex in its name. In reality, it is not at all difficult. So I hope you guys have the confidence to go ahead and attempt complex number questions if they come to you. See you in the next video.